Hello, my name is Jason Holmes, and this presentation is for CMIT 421 Project 1. In this briefing, I will present evidence showing how suspicious internal scanning activity was identified in a virtual lab environment. This presentation is organized into 5 parts. First, I will introduce the Ubuntu victim server and the Parrot OS scanning system. Next, I will review the Nmap and Nikto scan results. Then, I will show how the Apache access logs capture the activity. Finally, I will close with the main concerns and recommendations for improving internal threat detection. Slide provides background on the victim system used in the lab. The machine is an internal Ubuntu web server with the IP address 10.1.4.200 on interface ENS33. It was configured on the same subnet as the Parrot OS machine so both systems could communicate. This setup allowed me to perform reconnaissance and then review the resulting evidence in the Apache access logs. It shows the system used to simulate the attacker in the lab. I used the Parrot OS virtual machine, which is a security-focused Linux platform commonly used for penetration testing and security analysis. The machine was assigned the IP address 10.1.4.27 on interface ENS33 because it was on the same subnet as the Ubuntu victim server. It could perform internal reconnaissance using Nmap and Nikto. The Nmap scan results against the Ubuntu victim server at 10.1.4.200. I ran the scan from the Parrot OS machine to identify exposed ports and services. The scan found FTP on port 21, SSH on port 22, Telnet on port 23, and HTTP on port 80. It also identified the web server as Apache 2.4.41 on Ubuntu. The timestamp is important because it helps us correlate the reconnaissance activity with entries later observed in the Apache access logs. It shows the Nikto scan results against the Ubuntu web server at 10.1.4.200 on port 80. The scan began at 22:04:25 and identified the target as Apache 2.4.41 running on Ubuntu. Nikto reported several notable findings, including missing security headers such as X-frame options and X-content type options allow HTTP methods and a browsable backup directory. These results show that the internal web server was successfully profiled and probed, which is important because this type of activity will be a strong indicator of reconnaissance by an insider compromised internal host. This slide provides direct evidence of the Nmap scan in the Apache access log. By filtering the log for the source IP address 10.1.4.27, I was able to isolate requests generated by the Parrot OS machine. The entries show repeated probing behavior and explicitly reference the Nmap scripting engine, which makes the activity highly suspicious. This demonstrates how even internal reconnaissance can leave a clear forensic trail in standard web server logs. This slide provides direct evidence of Nikto scan in the Apache access log. By searching the log for Nikto related entries, I isolated requests originating from the internal Parrot OS system at 10.1.4.27. The entries show automated probing behavior against the web server, which is consistent with web vulnerability scanning. This demonstrates that internal reconnaissance activity leaves a visible forensic trail that defenders can detect through log monitoring. Demonstrates how tail can be used to review the latest entries in Apache access log during an investigation. The output shows the internal source IP 10.1.4.27 generated multiple suspicious requests against uncommon files and administrative paths. The pattern is useful because it helps distinguish normal browsing from automated probing activity Even without a full Simon, a defender can use simple Linux commands to isolate recent evidence and accelerate incident review. In summary, this investigation showed that an internal host at 10.1.4.27 performed reconnaissance against the Ubuntu web server at 10.1.4.200. The Nmap scan identified multiple exposed services, while the Nikto scan revealed several web security weaknesses, including missing security headers and browsable backup directory. Apache access log analysis confirmed that this probing activity was captured by the server and traced back to an internal source. The main concern is that this behavior may represent either an insider threat or a compromised internal machine. Based on these findings, I recommend improving internal log monitoring, reducing unnecessary exposed services, hardening the Apache server, and creating alerts for suspicious internal scanning activity. If this activity progresses beyond reconnaissance, the issue should be escalated into a full incident response process.